Especially 2? Okay.
No, like you said 2B.
2b, yeah. Well, I mean, I'll say this. Once you write the equation for 2b, shouldn't be too hard, but I understand we haven't done much with that, so we'll talk about that for sure. So let's start with 2. So Mitsu shoots an arrow from an initial height of 2 meters. Hey, let me ask you this. If it's an initial height of 2 meters, what is the distance that that arrow has gone? No? Think about it. So I want you to notice it reaches a maximum height of 20 meters, right? After it has flown a distance of 60 meters. So what do I have there? I'm going to come back to the other part in a second. What do I have? Say that one more time. How do we know that we have a vertex? Because it's a maximum, right?
You told me our vertex was 2.
Say again.
You told me last week the vertex was 2.
Not the vertex. Maybe I misspoke. But the I don't think I said vertex. There's another thing that I said the 2 was. Because notice again, a maximum is a vertex. How would I write this vertex? Okay, so remember, if it's a maximum height, that's up here. Is the maximum height going to be the x or the y value?
Why?
The y. So that's one thing to be aware of. So it'd be 60, comma 20. And that is a tricky part of this. But notice we have our distance that the arrow has flown horizontally. We have the height that is going as well. These are all details I would be writing down, because this is how we are approaching this question. A lot of us just wait to get the final answer. Just write down the final answer does not help you. You have to understand the how and the why, right? So that is a maximum height of 20 meters after it has flown 60 meters. So I want you to think about this again. Here's that initial height of 2 meters. How far has that arrow flown horizontally when it is released from the bow?
6.
Say it one more time. 0. Remember, the vertex, the maximum was at 60, comma 20. But when you release that arrow, how far is it flown horizontally? 0. So it'd be 0, comma 2. So what point is that, Lexi? It's not the vertex. And I apologize if I missaid that. What point is that?
Y-intercept.
That's my y-intercept, right? So if I'm trying to write this quadratic function, what form should I be using? But I have a y-intercept, so why not standard form? Isn't the y-intercept really easy to see in standard form?
But you can't do anything else.
Yeah, but do I know what a or b is? No. That was a bit of a trick question. Have we ever started in standard form? No, that's one of the key things we talked about on Friday, right? We don't ever start in standard form. There is a way to do it. We're not doing it. It is much more complicated. We have a vertex, so we're going to start in which form? Vertex form. So this is where I do want to remind you. Start with the most basic version. And when I say basic, I mean the generalized form. What is vertex form in general?
Parentheses x minus h close parentheses to the second power of plus k.
Please be careful and remember, because I already saw it on some of the understanding checks, we forgot that square. Is it quadratic without that square? Nope. Nope, 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 nope. You gotta be careful about that. And again, don't forget, like an understanding check is literally just a check on understanding. It's so that I can give you feedback to improve your knowledge and your understanding. And that understanding check grade is not final. However, some of us do need to take the understanding checks more seriously and actually study for them. Because some of the answers I saw maybe we just have that big of a misunderstanding, but I struggle to believe that we studied for the understanding check with some of the answers I was seeing. Okay? You gotta take time to study. Again, 10 to 15 minutes a night. Maybe take Sundays off, but 10 to 15 minutes is little enough that I would knock it out, or maybe do a little extra on Saturdays so that you do have a rest day, because I do wholeheartedly believe in rest days. Okay? But there's one thing I'm missing from this vertex form. Got an A.
Oh, you got L, the L parentheses X plus
And how do we read that F parentheses X? F of X, right? So F of X equals, right? We want a function there. So which of those values do I already know? Okay, so what is my H? 60, but I have an H of 20 right here.
I still don't understand why we wrote it down here.
So,
The maximum height is 20. It does.
and that's, well, and so I'll talk about that in a second, but that's what I want us to recognize is this height does not necessarily mean the same thing as that H, right? I'm using an H here to describe height in context. Does that make sense? Okay,
Like,
yeah.
it's, we wrote it as 60, comma 20, because the maximum height is 20. And it has, that's the Y, the 20 is like the Y. And K is, I don't know.
So the way that this problem is, and you're on the right path, the way that this problem is set up, we're talking about the maximum height, correct? Which the maximum height would be up here. Is the height a vertical or a horizontal piece? Vertical. That's why the height is 20, the vertical. And so remember, how far has flown is horizontally, that's an X direction, so that's a 60. So it's based on the context. Does that make sense? Okay. So f of x equals, do I know my a yet? No? Do I know, well, I'm gonna, hold on. Do I know what h is? What is it? 60. Remember, that's the x value of the vertex. Squared plus, what's the k? 20, the y value of the vertex. Now, at this point, I still need to figure out a. This is part of what your homework was in completing the other problem. How are we going to figure out what a is?
Is A two?
No.
I don't think
Could
so.
you plug in that too? For the
What could the 2
F-
be substituted in for?
The F of X.
The f of x. Remember, right, so we can't just say, hey, that number's going to take the place of a, but that is a y value or an f of x, right? This 0 is an x value. So I can substitute those in for x and f of x. So 2 is equal to a times 0 minus 60 squared plus 20. And then I'm just solving this equation. Because how many variables do I have now? Just one. Okay? So all I did was I simplified to start. Now what am I going to do?
Subtract 20,
Okay. What is that going to create?
a 0.
Yeah, I'm not just going to put a slash to it. It's creating a 0. Why do I need to subtract 20 from the other hand side, the other side of the equation as well? To keep it balanced, to make the equations equivalent. Right? They will have the same solution, which makes both equations true, but the whole idea is that the equations need to be balanced. And by the way, like, I know you have some space to show work there, but if you need a separate sheet of paper, get a separate sheet of paper. In the future, like if you have to graph, and I saw some people graphing on lined paper, what else can you graph on to make graphs easier? Graph paper, right? I have lots of graph paper. Ask for it. I'll be more than happy to give it to you. I buy it using my school money for you all to use. Why am I dividing by 3,600? Right, to get a 1, 3,600. Excuse me, divided by 3,600 is 1. And so A is equal to, yeah, that's not something most of us know off the top of our heads. Pick up a calculator.
You said I'm good.
I
He
s-
said put it under your desk.
Oh.
It walked in and you told him so he guess it.
He didn't put it back.
I said, yeah, I said you'll want it later today, you just don't have it out on your desk. My bad. But yeah, it was just for the understanding check, right? Because you could have graphed any of those equations to get those features. Yes, ma'am?
Since X equals H, why don't we never put, agglutinations?
Oh, one second. What did you say, Jada?
Okay, the axis of symmetry is equal to H.
Correct.
So X equals H, why don't we never put that in the equation as X? Like,
Well, I mean, you would say that the axis of symmetry is x equals 60. But what are you trying to do? You're talking about why wouldn't we put 60 in for x?
yeah, like in the equation.
Well, I mean, that's just gonna give you the vertex, or the axis of symmetry. X is a variable, and so we want that variable to be able to change and to move. So we're not gonna put 60 in for x. Like, what are you trying to solve for or identify if you put that 60 in for x? Say again?
Nothing, never
Okay.
mind.
I'm trying to answer your question, I'm just not quite sure why, like, yes, x could equal 60 100%, but if you substitute that 60 in, all that's gonna leave you with is the value for k. And that could help you find the vertex, but I've already given you the k value for the vertex. Okay, so you just don't need to. But what is a again? Close. Make sure you put the numerator in the numerator and the denominator in the denominator.
Negative 1
-1 divided
divided by 200.
by 200. Now I have everything I need for that equation. So f of x is equal to -1 divided by 200 times x minus 60 squared plus 20. There's the equation. Right? And that's what we worked on Friday, and we'll get some more practice with it here. So how would we determine the height of the arrow after it has flown a distance of 100 meters? We're making that more complicated than it has to be. Could that 100 meters be substituted in for any of the variables? Isn't the distance my x variable? So what could that 100 be substituted in for? Not for 60, x. That 100 could be substituted in for the variable x. Now be careful, right? The 60 is h, right? 60 is the x value of the vertex. I can't ever substitute anything in for that. But what I could do is I could do f of 100. Notice how, what is that 100 taking the place of? X. And so I substituted in for x, and then I just simplify that expression on the right-hand side. That's it. Is that easier than you thought it would be? Yeah. You just have to identify what variable are we dealing with. That's it. Okay. So I'll go ahead and point out number 3 should be pretty straightforward based on what we did with number 2. Again, if you feel like you don't fully understand tonight when you get home, I'll post the video so that you can watch again on what we did with number 2 to help with number 3, where we talk through everything.
Somebody said you number 1.
Huh?
Somebody said you number 1.
Yeah. I was about to. I just was waiting to erase. This afternoon, yeah. Don't forget, by the way, to do the right portion. A handful of us forgot to do that right portion last time. Hey guys, slow down. Make sure you're attending to all those details. Yeah. So, looking at number 1, write a quadratic equation for the parabola that passes through the point 2, -3 with roots -6, 0 and 4, 0. Again, and most of us did not do this on the understanding check, and it hurt us because I saw us already writing the, well, which form am I going to start with?
I use factor.
For number 1, which form of quadratic equation are we going to use?
I use factors. Does it all use roots? But yeah, it'd be factors.
So I hear factored for more people than I hear vertex. What do you think, CD? I hear you saying vertex. Why are you thinking vertex?
The first one is vertex, the first form.
Say that one more time.
The first one is vertex form.
Is the first point a vertex though? Does it tell us that?
It doesn't say it's like somewhere in.
It just says it goes through that point. We need to be careful. It never tells us this is the vertex. Notice down here in number 3, use your knowledge of reference points, which don't worry about that part, to write an equation for the quadratic function that has a what? Vertex. If it's a vertex, they're going to tell you it's a vertex. What do you think now? Factored. What do we have here that's telling us factored form? We have roots. Notice how every time I start by writing the general form, I didn't see a single person do this on the understanding check. I would do it every time. What is the general form for factored form? F of x. It's always been a. That a starts us off every time. X minus r1 and x minus r2. Okay? Which of those values do we already know? R1 and R2. If you take the time to substitute it in just like this, you get a times x minus -6 times x minus 4. Anybody forget that when we subtract a negative, it actually changes the sign? We're not turning this in today. We're turning in the graphic organizers if you have that ready to go.
Yeah,
Yeah.
it's right here.
Okay?
My name on both or stapling?
Put your name on both, so I can easily scan it. Okay? I always scan your understanding checks and your homework so I have a digital copy of them at
Oh,
all
no, I thought
times.
you meant scan it to grade it. Like, I had a teacher who did that, and she would get all of our grades wrong, like really badly wrong. Like,
No.
kids who were supposed to get 100, they'd get like a 20 because it was like.
Yeah, that's not how I do it. Notice when it was a root of -6, we got x. When it was a root of -6, we got x plus 6. Remember when it's that x minus, we always get the opposite of what is there. We need to be careful about that. I'm not going to work all the way through this, but how are we going to figure out a? What can we do? Substitute what in? So we've already used all of this, we can't use it again.
The 2 and x.
Okay, what's that 2 going to be substituted in for? X. What's the -3 going to be substituted in for? Y or f of x. So x and y. -3 is equal to a times 2 plus 6 times 2 minus 4. From there, all you got to do is solve for a and you can get your equation. Do you need me to make something bigger, Cameron?
No, I just couldn't tell what number that was for some.
Gotcha. So, is it safe to say we can solve for a from there and get our equation? We don't need me to finish? I will say we're going to look at some practice problems where we do more with this today as well.
You want to go to practice problem like that?
What do you mean like that? Where you have to get the A like that, yes. Also, if you look at lesson 4, it has step-by-step examples walking you through it. Okay? So, don't forget, use your lessons. This is practice problems for lesson 4. So if you need help with some of these problems, where could you go? In the book, right? Take advantage of those things. Specifically, I think it was 4.3, wasn't it? That this is from?
I don't think I did this right.
It's just the right and the practice. Yeah, 4.3 is where it says writing a unique quadratic function, and it has us solving for that A. Right? And it gives us both an example in vertex form and in factored form. Yes, Lexi.
Can you look at this? I don't think I did it right.
Can I get us started with class, and then I'll come check it?
Mm-hmm.
Cool. So, we're trying to use key characteristics of specific forms of quadratic functions to write equations. This is the last little detail from 4.3. Oh yeah, here's those words out problems, right? So, again, don't forget, this is in the book. I explained it more in the video on Friday, or when we talked about it on Friday, how they took some of these steps. So you can go to that and check it out if you want, but it also tells you pretty well exactly what to do. Notice how did they ever just substitute values in right away? No, they wrote the equation first. Every time you write the equation, you're going to remember it better. Every time you take the time to substitute those values in, you're going to notice, hey, when I subtract a negative, it becomes what? A positive, right? So when it's a negative root, I'm actually going to get a plus. When it's a positive root, it's still going to be a minus. Take the time. Okay, so here are the two problems I asked you all to complete over the weekend. I told you I was going to operate under the assumption that you had completed them. Notice this is exactly what we just looked at, right? We have a vertex and a point. We substitute our vertex value in. Right here. The -3 for h, the 4 for k. And then I substituted in my x and my y, solving for a from there. So I found out a was -3, and there's my equation. Same exact process for b. If you do not do that homework, I might write this down so again you have notes. Might also give you a chance to realize, hey, I should ask a question here. But these are the parts of being a student that we gotta get better at.
Confused about something, but I'm not so sure what exactly it is.
Let me know if you figure it out.
I got the same. I just ended up different.
Well, so remember, you haven't actually found what a is yet.
Okay.
So you substitute that 4 in for x, right?
Mhm.
But that 0 then can be substituted in for y or f of x,
Okay,
right? So
yeah,
that's what I
did
did
that.
here. I substituted the 4 in for x, the 0 for f of x, and then I had to solve for a.
Oh, okay.
Once I got a, I was able to write that. So again, that's the whole point. If we do this homework and we have questions, we can check our work and say, ooh, I made a mistake here. All right, so what was your question, Lexi?
I don't think I'm doing this right.
I mean, 2 plus 6 is 8. 2 minus 4 is -2. And then what's 8 times -2? So you have -3 is equal to a times -16. What can you finish? What can you do now to solve for a?
Do I?
Okay.
I was.
That's all you have to do.
I just said
And then once you get your a, yeah.
just forgot to put.
So like you started to substitute in,
Yeah, I was like y equals, and then it just like, nothing,
but then you didn't substitute anything in for y, so you couldn't
Yeah.
solve for a.
yeah.
So we want to recognize that that point gives us both an x and a y, so we substitute our x and y. And this is what happens when you work through it. You realize, oh, these are the mistakes I'm making so that you don't make those mistakes in the future. I know it sounds crazy, but homework has a very important purpose in your learning.
We weren't supposed to do the third one, right?
Nope. Because remember, could we do the third one?
No.
No. We had no vertex, we had no roots, so there was no way to do the third one. Okay?
Except you said there was some really complicated way to do it.
It's not like super complicated, it's just a super algebraic method that we're not gonna get into. Like, there's actually a way to do it in the calculator with 2 steps, but the algebra behind it I'm not going into because it's not a focus for Algebra 2. And we're also behind.
Yeah, at first I started.
If we were ahead, I'd probably do it, but we're gonna be lucky to get all the way to trig, which we really need to get to trig. At least the basics of trig. If you take pre-cal, Ms. Beasley will go into deeper levels of trig, but I need to at least get to the basics before we get to pre-cal. Or you could always take stats and then not have to worry about trig ever again.
Ooh, that sounds nice.
At least in high school. I don't know what you plan on doing after high school. Unfortunately for you, Cameron, we've got so many years, you got 2 more years of math. Go ahead. It'll be good for you long term. Alright, looks like we're for the most part done writing this down. Lexi, you got a little bit more, and Jada. Really? Unfortunately, it's not how it works anymore. Maybe. Hold on, let me think for a second.
They give you the
I
first term.
thought
then
that
like-
you had to do 4 years of high school math no matter.
Give you the-
Or if you just did enrollment, you
Vertex.
In high school is what it, I thought they the new formulas.
Yeah, so I guess you base it on what you're trying to find. So if you're trying to find A.
You gotta have this class, or you gotta.
Well, you have to take at least one
Yeah, I
more
know, that's what
class.
I'm saying. I gotta.
I will say this, I would take one senior year if you plan on going to college. Having a whole year gap of no math before college can get bad. So you have to get the algebra 2 plus
Well,
1.
I didn't miss it, I mean, I'm still
Okay. Alright, so we already talked about no equation there, so we'll get into lesson 5. So here's what I need you to understand. We need to start solving quadratic equations. That's what we're getting into. Traditionally, we solve quadratic equations very algebraically, meaning we focus on the what?
algebra.
Okay, where do we see algebra? With what? Equations, right? We very heavily focus on equations. However, y'all live in the 21st century. So what can we use to help us?
Calculator.
Calculators. Specifically, what representations on calculators? Graphs. We're going to use those very heavily so that we don't have to rely as much on the algebra. So we're going to use graphs to determine the roots of quadratic equations. What's another word for root? X-intercepts. What else? There is another word. Zeros, right? So we can call them x-intercepts, we can also call them zeros, and they're called roots. It depends on the representation that you're looking at. It's known as the root of a polynomial because there are other types of functions that have roots as well. They're called zeros because the y value is equal to 0. And they're called x-intercepts because it's where the function intersects the x-axis. Unfortunately, we will find out in another lesson or so that sometimes there are zeros or roots that don't intersect the x-axis, which is why we need other names. Yep. So where we get into what are called complex numbers. Not terrible, but we just have to learn how to use these things. If you learn how to use a graph to rewrite quadratic equations of the form, what form is this? Standard form, into vertex form, you're going to be golden when it comes to complex numbers. If you can learn to rewrite quadratic equations of standard form in vertex form, you'll be golden. You can also learn how to use the quadratic formula to determine roots and zeros. So yeah, but it comes in working from the graph perspective. So you know how to use properties of equality to solve equations in these forms. Let's at least do A together, then I'm going to release you to work it within your small groups. So, what can I do to start with solving for A? Add 9, what's that going to create? Everybody good that adding of 9 creates a 0? Yes? Alright, say again. Lesson 5, the root of the problem. In 1-81. Is that what y'all said? 80.
Sorry, my bad.
Yes, that's right. It's just the getting started part. That's right. Huh? Yeah. Okay. So adding 9 there creates that 0. So what's on the left hand side? 36. 36 is equal to x squared. Now what do I need to do? Divide by what?
X squared.
Can you divide by x squared?
No, that's the answer.
1 squared?
So I want you to remember division is the inverse of what? Multiplication. I don't have pure multiplication. What is the inverse of a square? Square roots. Okay? Huh?
I don't like that.
Why not? You know you can use a calculator to get a square root, correct?
Yeah.
I forgot.
I mean, you can do a lot of things in the
Oh, there you go.
calculator, but like,
Okay?
I don't know how.
There you go.
So let's make sure we know how.
Yeah.
So there's the square roots. And the big thing to notice is, and we'll go into more detail about this later, but the square root and the square are inverses, so they cancel, and they'll technically create an exponent of 1. So x to the first now is equal to 6. Close. The 6 is not necessarily wrong. Before we get into that, does anyone need me to show you how to get to the square root on the calculator?
It's
Control
it's
and the check sign.
It's control and
Control and the check.
X squared.
Check.
And then X.
You don't have a calculator?
Okay, so
If you need to
control.
learn how to use a calculator, go get one.
Wow.
So, if you look at the square, is that what y'all are referring to?
Yeah.
Okay, it's not a check thing, but it is a square root, that's what it's called. No, but that's not a mathematical thing, it's a square root, we need to learn to use the proper vocabulary. Okay, but then remembering it that way is going to hurt you long term, it's called a square root. So here's the thing though, alright? So it's a control and then the x squared button is where you get the square root. Everybody see that? We get to go there? Okay. Now here's what I need you to pay attention to. 6 squared. Does that equal 36? Yes. Notice I substituted the 6 in right here. That 6 makes the equation true, so is that a solution?
Yeah.
Can anybody think of another number that is squared and it gets 36 though? Negative 6.
I thought that's the problem that you did.
So x is equal to positive or negative 6. Okay? And that's how you can write it, plus or minus on top of each other like that.
That is going to calculate.
What?
Negative 36.
You need to be careful about the way you're substituting it in. Put it inside of parentheses. Okay? The calculator follows the order of operations. And so when you actually write negative 6 squared like this, it's going to do the exponent. And it's going to understand this as negative 1 times 6 squared. So negative 1 times 36. So if you don't do the parentheses, you do get negative 36. Right? But remember, literally at its core, if I do negative 6 squared, that is negative 6 times what? Negative 6. And what's a negative times a negative always going to be? A positive. Okay? So really quickly, I want to point this out before we get too far. Let's say 4 is equal to x squared. So what could x equal? Not 4. Positive or negative 2. Because what is 2 squared? 4. What's negative 2 squared? Also 4. Let's say 100 is equal to x squared. What could x equal? Positive or negative 10? Nope, not 100. Positive or negative 10? If I have 5 is equal to x squared. It says divided by 2. I'll let you in on. Did you just put square root of 2 in the or square root of 5 in the calculator? I'll let you in on a quick little secret. I don't care about the decimal.
So it's gonna be 2.
So it'd be the square root of 5. You can't just drop off the decimal, but can you leave it as the square root of 5? Yes. Do we still need the plus or minus? Yes. You still need the plus or minus. So what is a note that all of us should write to ourselves on this getting started? Right? When you take the square root in an equation, you're going to get a positive and a negative. So when you take a square root in an equation, to solve for x, you get a positive and negative. Every time. You gotta recognize and remember, when you take a square root to solve an equation, you get both a positive and a negative. Every time. Does that remind anybody of any operations or any types of equations we've already looked at this year? Say it again? Absolute value, right? Remember with the absolute value of x is equal to 4, well x could equal 4, but x could also equal what? Negative 4. Right? Same idea. You gotta keep in mind that you're gonna get both a positive and a negative. Which I will go ahead and let you know. One of the homework assignments that you will have due on Friday, and I say one because there may be another, but it probably won't be until next Tuesday. You will have some absolute value equations as a review. I would do those early so that you can ask questions on Thursday. Alright, so let's take hopefully no more than 10 minutes or so. Let's solve these equations. That may be where we end today. Work within your small groups, help each other solve these equations and find what our solutions to each equation will be. Any questions?
Just B, C, and D.
Just B, C, and D. The what?
That being x to the side, we want to simplify it for equals 1 to 4. One is not on both sides, we do x to the second equal 3. And that's what I want to put on the little squiggly line maybe. Yeah, it's on the class.
What?
Okay, how is it?
So, well, first off, if you're going to do that, remember it's got to be
I have to write it.
x plus 3
X plus
times x plus 3,
yeah.
right? That's what it means to square. So then what would you have to do? You know what that's called? Distributive property, right? But there's an easy way to do it. Remember, you can use an inverse to undo that square.
That was fair.
Is division the inverse? Right. Can't you go ahead and take a square root from there?
So it doesn't matter if
So remember, that square is outside of the parentheses, right? So then, and that's gonna, it's the inverse of that square. That square is outside of the whole thing, so you can just take square root. What do you mean?
I fell out of the tree.
Remember, the whole point is that the square root is the inverse of the square, so there's no what?
I was just running right in the woods up here.
It just cancels. You're left with x plus 30 is equal to what? Nope. Huh?
Plus nine.
What do you have to do?
I
You
got
gotta use a
x
property of
squared plus
equality.
3x plus 3x plus 9.
You would square root the entire thing, is that correct?
So that's if you do x times x, that's x squared. Or x times 3.
No, you don't have to put it in.
3 times x.
So it's not 3 times 3.
Yeah, I think so.
Oh, and then you saw it.
And then,
And what's funny about
Oh,
it.
wait.
No, that's bad and bad. It's like double Google.
What did you just say?
I'm really weird since I got my and then they call Andrew, but not my brother, who's 20 and in the car. Andrew.
What's wrong for
Yeah,
negative?
to come pick me up.
Group one, let's focus on the math.
so it's
So positive and
He
negative.
picks up me, Ashley takes me.
Grayson, let's focus on the math.
Mr. Kenny,
Okay,
Hold on one
so
second, let me get
C.
y'all's homework scanned so I can give it back.
I don't know.
How do you multiply first?
you want it
So
to
like
like
x, because it'd be 3
Yeah.
times x to the second times, minus or plus, what's negative 1 in the second?
Well, except we don't care about the decimal, so we can just leave it.
So
So square root of 48, I square
Plus 3.
Plus 1, no.
so equals.
Yeah, but we never, oh yeah, cause, yeah, if you multiply, yeah, 3x to the second plus 30. So 48
What if
equals,
it's
minus 30,
x
45
squared,
equals 30.
Focus on using your inverses.
6x squared, so there's 2 x's.
Which one? But the one doesn't have a.
So what we did first
So we can't do that. Well, I did distributive, like after I squared root that, then I did 3x minus 30. Like I did that distribute first, so then I get square root of 48,
What was your question?
3x minus
We can't combine these, right, because one's not really.
3. 3 plus negative.
Correct, you're also making your life harder than it has to be. 3, sorry. Is there any way to undo that square?
Yeah, we did that.
You distributed. I said undo it. What's the inverse of the square?
Oh, shoot.
Square root. By the way, x is equal to plus or minus 6, right? You took the square root to cancel out that square. That's the whole point, is that they're inverses. So when I take the square root here, that's going to cancel out the square, right? It's the inverse, it cancels it out. So what am I left with on the left-hand side?
What'd you get after you multiplied?
So x plus 3. What am I left with on the right-hand side?
Minus 30.
That's what I was saying, I would add 30 to this.
Remember, I took the square root, right? I had to use a property of equality. Plus or minus 11.
You have to leave the square root. Did you still have to subtract?
Because I need to solve for x.
You squared it.
And so there's a few different ways to show it. You can do it separately as negative 3 plus 11 and negative 3 minus 11, right? You're just splitting up the fact that it's plus or minus, and then you simplify.
15 squared.
Yes, ma'am?
I have another question.
Lindsay, can you take that?
What's up?
So for this,
Yeah.
So when we leave the square root to 48, are we allowed to add 3 to make it square root?
Before you get there, so remember, you were able to take the square root of the square because the square was the outermost thing. Is there anything outside of even the square? Well, it's not that. So if I were to have 48 is equal to 3 times x, what would you do to solve for x? So then you would divide. If I have 3 times x minus 1 squared, can't I still divide? So now what are you gonna do? Now, you haven't taken the square root yet, right? You divided by 3 to cancel out that multiplication. Now what would you do? Now take the square root. Why?
So you would just divide,
So I had multiplication by 3, right? Is that 3 being squared? No. So I'm not gonna take the square root of that 3. But what's happening between the 3 and the parentheses? They're being, so I'm gonna go ahead and divide by 3 so that I get to just the square root, or just the square.
you take it this way.
Well, I'm making a 1.
Yeah, well.
So that you're left with just the square. You're gonna divide by 3.
so I'm thinking the square root of 10.
Not 10. What's 48 divided by 3?
Or 16.
So when you take the square root of 16, what do you get? Correct. 4, are you just gonna write 4? No. Well, say that what you're saying again? Plus 4, minus 4. So you gotta do both of those and then solve it from there. Yes, ma'am.
Do you minus 14 plus 3 or minus 11?
So how did you get to x? You subtracted the 9. So instead of doing it that way, what did we do in A when we got to the square?
Is this our answer?
We did the square
We
root.
have to solve it.
What can I do here to get rid of my square? Well, right, so we'll just remember it's already squared, so what are we gonna do to undo the square? Square the root. Right? And you're right, the square root of 121 is 11. Now are there any other numbers? Right, so remember it's plus or minus. And the whole point is that that square root and that square do what to each other? Cancel each other out, right? And so what you did is perfectly fine, but if you can have a square, it's much easier just to end up taking the square root. Does that make sense? So solve it from there. How's it going over here?
1/2 x squared equals 1.
Go back.
1/2 x.
Oh, I just divided that
I did not. And then there's over the
So how did you get 3x squared plus 3? Did you square each of those numbers? So, 2 things. One, we're going to talk about up here as well. Remember, x minus 1 squared, that's x minus 1 times x minus 1. Go back to the basics. So can you just ignore that? No. But hold on. Also, didn't we take a square root up here? Did you ever take a square root? For, like, early on, I guess you ended up taking it. But look, what's happened between the 3 and the parentheses? They're being what? So what could I do to undo that? By?
Yeah, and then you have to square root it.
So then 16 is equal to x minus 1 squared. If I have a square, what can I do to undo that? Square root. I don't have to distribute it. I don't have to square it. If I take a square root here, isn't that going to cancel out that square? So it's just making sure that we understand that the inverse of a square is a square root. Once you know that, you can solve the equations much more easily than having to multiply the x minus 1 times x minus 1.
So what would this be?
Well, what's the square root and squares are what?
So this x minus 1 would go away.
No, the x minus 1 wouldn't, but the square root will cancel out the square. So I'd be left with x minus 1 equals something. Okay, so let's start going over this. Let's start talking about it. How was it? Hard? Wasn't easy at first, and that's good. Remember, I know that we want things to be easy. Are you learning if it's easy? No, you are not learning if it's easy, you just feel comfortable because it's easy. Alright? So, a couple of things I want to point out here. Because I saw a lot of students doing this, which I get it, but be careful, I've warned y'all about this. When I look here, I saw some students doing x squared plus 9. What's the issue with that?
It's wrong.
Okay, but why is it wrong?
Because that
Would be
square three.
X plus 3 and X plus 3.
So it should be, right, they're only squaring the x and the 3, but it should be x plus 3 times x plus 3, right? And then what are we going to have to use from there? You would have to distribute if you want to go from there. So I get x squared plus 3x plus 3x plus 9. Don't write this down, okay? Usually I would say write it down, but I want you to look at this again. Do you know how to solve this with both an x squared and an x all at the same time?
No.
No. So should we be squaring the x plus 3? Nope. Okay? So I need you, and I want you to notice, like I intended to use these problems to talk about this issue because I want you to recognize we don't want the x squared plus 9, or x squared plus 6x plus 9. So 1, it's not x squared plus 9. You have to do x plus 3 times x plus 3. You got to distribute. But it's x plus 3 squared. What is the inverse of a square? A square root. And so, using a property of equality, I got to do it to both sides, but some of us were struggling with this and didn't like it, but remember, what's the relationship between a square root and a square? They're what? There's an I word for it. Inverses. They're going to cancel each other out. And quite literally, the square root is going to make this exponent of 2 a 1, right? So we don't actually have to write it. So x plus 3 is equal to what? Close.
Please pardon the interruption. I need to see the following students to the front office, please, to pick up
Say
the
again?
materials. Javarian
Just
Hartley,
one.
Elizabeth Wilson,
Right. We've got to write the plus or
Elizabeth
minus.
Ford, Brandon McGuire,
Now, there are two
Yolanda
ways to
Reynolds,
write
and
this.
Gerald
You
Frick.
can write it just like
Thank you
this.
very much.
Or you can write it as x plus 3 is equal to 11 and x plus 3 is equal to negative 11. You can write it either of those ways. I prefer this one because it's shorter, but it's your choice. So I subtract 3, and we just need to be careful and be aware that x then is equal to negative 3 plus or minus 11. What is negative 3 plus 11? Negative 3 plus 11, use calculators. Is that what we're guessing? Just use a calculator, come on, pick it up.
Negative
8.
Negative 3 plus 11 is a positive 8.
Or negative.
Or negative 11, okay? And so, I would do it that way every single time, but notice you can also just do it this way. Notice x is equal to 8, subtract your 3, x is equal to negative 14. This one is much more plain, you see it right away. You just have to be aware that it's going to be plus or minus 11, minus 3, right? So you have to be careful with that to make sure you're doing it correctly. Lexi, you look like you have a question.
How is one of them negative 11 and the other one negative 14?
Well, oh, I miswrote that. Thank you. Because remember, it's negative 3 minus 11 is negative 14. I just miswrote it. Thank you for catching that. Okay? So, we should finish up with lesson 5 by Wednesday, just so you're aware. Which is where, oh no, tonight your only homework is to finish up M1-77, write and practice numbers 1 through 3. I mean, we've already talked about half of those problems, so we should be able to knock it out pretty easily. Try not to have too many homeworks missing. If you have not turned in the graphic organizer, I'd probably make sure I get that done tonight, so it's only one day late. So, I do not think we'll finish up lesson 5 tomorrow. We will probably finish it up on Wednesday. Just be aware, that means I'm looking at one last understanding check either Thursday or Friday on this lesson 5 and lesson 6. Testing Monday, probably Tuesday of next week. That is what we're looking at. Testing Monday, probably Tuesday of next week.